Welcome back. In this lecture, we will go for this question. Hexagonal pyramid, 25 edge of base and 50 height is freely suspended from a corner of its base, and the axis appearing to make 45-degree with the VP. So let's start with this question. So hexagonal pyramid, when it is resting on HV. So for first condition, we will make this pyramid rest on HV, and from the top view we will have a hexagonal face along with the slant edges. So let's go with the polygon 6 H method. First point and base edge is 30. Sorry, base edge was 25. First point, base edge is 25. Just going to move it a little bit in the lower direction. Now, okay, name the points. These I'm starting with A here. These corners are from A to F. So right now this thing is not complete. When our pyramid is resting on HP, this is the base face. Now from the top we will have slant edges along with the base face. So just going to draw these slant edges. Also they will be in solid. They will be in main drawing because slant edges are visible from the top view. So I'm going to mark center of the hexagonal face as small and the top point at which all the faces or the edges are converging. Going to mark it with 0. So this small O is for the center of the bottom face and top point is denoted by 0. So this is our front view. You can see our this hexagonal pyramid. The base edge length is 25 mm. So start with this. First I'm going to define the center line, and the height of this pyramid is 50 mm. Now just draw these construction line to create our front view. Again, these two corners B and F will be on the same line. Similarly, C and E will be on the same line. Now you can connect these 2 points. This top one is 0 dash and this bottom center is O dash. Okay, connect the remaining lines. So just change them to the main drawing. So this is our pentagonal prism, pentagonal pyramid, which is resting on HP. Now the height is 50 mm, base edge length is 25 mm. So now it is freely suspended from a corner of its base. So here you can see this T represent the individual point here, and the front view this point represent D dash, so just going to mark them. This one is D dash, this point represent C and E. This one is O dash, and this one B and F. O dash. This point is A dash. So now this is a front view which is traced out from the top view. So now next point is to define. It is freely suspended from one of its corner of its base. So in the base we have these corners, and this point D here represent only a single corner, A dash represent an individual corner. So either you can rotate it to the left or to the right, or just going to define a point of gravity from this line, which is in this case the the center of gravity will be at a distance of 1/4 of this axial height. So 1/4 of this axial height is 12.5. So just going to create a line, this one here. So just going to take a offset of this line. So 1/4 is 12.5. Okay, I need this point here. So just going to create another line from this T and connect this point here. Now I don't need this line anymore. Just remove this. Now you can mark this point as center of gravity, or simply G dash, or simply G. Okay, now in this question what we're gonna do, it is given in the question we have to make this thing freely suspended from one of a corner from its base. So this T is one of the corner in the base of this pyramid. So I'm going to suspend this pyramid from this corner. So logically you can say if something is freely suspended, so under the gravitational force it will be in the directly downward direction. So from here what we can do to make sure it is freely suspended, but we can take as a reference is after rotation this T dash G become directly should be a straight line which should be perpendicular to this thing. Simply just select this thing. Now make a copy of it first. Now rotate it in such a way that this line, which right now this T dash G, which is inclined at some angle with HP, after rotation it should become vertical to this one, this reference line. Okay, so simplest thing is to do is just measure the angle between these two. Okay, to perfectly make this thing vertical, what I'm gonna do from the format, I'm just going to change the angular precision. Previously it is okay, it is 0.0. So we will have the angle in angle will be in 0.0 degree. It means if the angle is 32.5, it will come as 32.5. So here you can check the angle between these two lines, between the reference line and the inclined line we have 26.6 degree. So I'm going to rotate in such a way that after rotation it will, this T dash G dash line will come here, it will become straight. So the simplest thing is to calculate this angle first. Now from here to here you can see this one is 90, from this line to this horizontal line 90, and this one is 26.6. So you can do one thing, just add up these two angles, 90 plus 26.6, and the remaining angle from this line to this one is, you can check this, this one and this one, 153.4. So to make this line from here to here, initially it is at an angle of 153.4. So how much, with how much angle should I rotate this thing? So it will be inclined it here. It will rotate and come to this point here. So that's the remaining angle which we should consider. So just this one is one from 270, 153.4. So I will rotate this thing by 116.6. This one is 153.4, and from here to here total angle is 270. So remove this angle from total angle, you will have the remaining angle which is 116.6 degree. So if I rotate this thing by 116.6 degree, it will come here. So just select this whole thing and rotate it about this point, because this is the point from which this pyramid is freely suspended, and rotate it by 116.6 degree. Now you can see this d dash g is vertical, and further to make sure whether it is vertical or not, visually it is looking like vertical, but to be sure, just measure the angle between these two lines. So it is 90. So this thing is exactly vertical. So the point is, why we are doing this, because as in the question it has been asked, the thing is this pyramid is freely suspended from this corner. So now you can see under the gravitational force this thing is vertical to this surface line. It means it is freely suspended from this line. Now we have to trace this top point as well as this hexagonal face. So we're going to start with this top point, 0 dash. Again here 0 dash is on this line, so this point is our 0 top point. Now we need the bottom hexagonal face, which is represented by this line here. So let's start with d dash. D dash is on this vertical line, and here d is on this horizontal line. So just mark it like this. So this intersection point will give d. Similarly, on the same horizontal line we will have our next point, which is a. So again create a line like this and extend this line. So the next intersection point will give us a. Now next points are B and F, which are on the same vertical line. Draw a vertical line now from point B, which is on this horizontal line. So create a line here. So this intersection point will give us B, and F is on this horizontal line. So it will intersect here with this BF dash line. So we will have F here. Now the last 2 points are C and E. So just draw a vertical line from this C and E dash. Now again C and E are on the same horizontal line, so they're intersecting here. So this point is E and this point here is C. Now connect all these points. So when I say B, D, F and again A. Now make them or change them to the main drawing. Now connect this slant edge. This is our top point, this is one of the corner, and change it to the main drawing. Now you can remove this extension line to reduce the confusion here. So just going to remove all the construction lines. Now this is our top point and these are corners, so just going to connect them one by one. So these are our slant edges. So when it is really suspended from one of its corner, which is in our case D dash, it is suspended from D dash, and this is our front view, and from this we have traced out our top view. So these three, you can see this A dash 0 dash is at the bottom side, so this will be invisible, and again these two will be invisible to directly from the top. So what we can do, just going to make them hidden lines. These dash lines represent hidden lines. They are directly at the back side of the body. So this is our top view, which is traced out on this one. Now, as per the third condition, okay, one thing is left. We have to trace out the center line, central axis. So this is our central axis. So this is O dash here, and O dash here is on this horizontal line. So this is our point. I'll connect this thing here and make it axis. Okay, there's one more line at the back side. Either remove it or no need to do anything. This is a okay. Again, this is at the back side, but this edge will be, this is in the middle of this body, so just going to mark this thing and change it to the solid, because this is visible from the top side. So this is our body. Now, as per the third condition, it is given the axis appearing to make 45° with the VP. So third part is the simplest one. Just make a copy and rotate it in such a way so that the central axis make an angle of 45° with the HP. So when I rotate it about this point here by 45, this will be the rotation. Now I have given plus 45, that is why this is the rotation which I have. If I do the minus 45 angle, or if I give during rotation, if I provide minus 45, then this hexagonal phase is in the downward direction. Both the cases are correct. Both cases are correct as long as this central axis makes an angle of 45° with the HP. This is making 45, so this is correct. And the previous view in which this hexagonal face is on the top side direction, that is also true as long as this axis makes an angle of 45° with the VP. So just going to trace out the front view from this top view. First thing is 0 top point. So here we will have 0 dash. Just copy this thing and put it here. Now next we need to trace out this hexagonal face. So we will do A. Again A is also on this horizontal line. So start with A. This is our point A, intersecting, which is intersecting here. So this going to become A dash. Now next thing is B. Just starting with the extreme points first. So this D will lie on this horizontal line, and from here this is our D. Create a vertical line. So this intersection point will be D dash. Now next point is E and F. This one F, and B and F lie on the same horizontal line, which is this one. So this point become F. Just mark it F dash, and this one is B. Second point is B. So from B, just going to create a vertical line which will intersect with the same line as of F. So this intersection point is B dash. Now we have A, B, and F. Now the remaining point is C and E, which are on this horizontal line. Now from C, draw a vertical line. This point is C dash. Now for E, again draw a vertical line from here. So this point is going to become E dash. So all 6 points are there. Now just connect these points as A, B, okay. Now connect a corner. This one is C dash corner and this one is short point. Now change this line dash and all this base edge to main drawing, and now you can remove the construction lines. Okay, now connect all the corners to the top point. Now you can change them to the main drawing. So this is our hexagonal pyramid. Okay. And what we need to provide, we need to in the top view you can see these two lines are here. If we observe this thing from the front, means downward direction, you can see these three edges will be at the back side of the body. These three will become hidden. Now what we need the central line or axis. This is here up to here. This point here is okay, sorry, just forget to mark this point, which is the center bottom faces O. Again this one is again here is O. Now this is the center. From here draw a vertical line which will intersect here. So this point here is O dash, center of the bottom face. Now from this connect the top point. So this is our axis. So now you can see this is our projection for this thing. Now from this figure, this is our final solution in which you can see we have a hexagonal pyramid which is resting on HP on any of the base edges, and while it is resting on HP, this is a front view. This bottom line which is on the reference represents this hexagonal face. So we have to make sure this pyramid should freely suspended from one of its corner. So this point D dash is one of its corner, and again I have make sure this pyramid is suspended from this corner. You can make it freely suspend from this one. Again follow the same process, just connect this line with the center of gravity, and this center of gravity point is at a distance of at a 1/4 distance of the central height from the base. You can see the main axial height of this pyramid is 50 and 1/4 of this height is 12.5. So from the base this point G should be at a distance of 12.5. So this thing is freely suspended from this point D, and as per the third condition you can see while freely suspended from the point D, the axis makes an angle of 45 degree with VP. Okay, thank you.